Today, we're talking about the structural engineering work process. How do they look at a project? What are their main concerns? And what is the process from start to finish to develop a structural plan? I'm Dave Edwards with Earthbound Homes.
I'm Jason Powers with ZFA Structural Engineers.
And let's take it away. So, Jason, thanks for joining us again, and I'm looking forward to this next topic because I think it's super important, which is all about the structural requirements in California, which is obviously where we are. And so, tell me a little bit about the forces that you have to deal with in California, specifically related to earthquakes, and now we have snow and wind and really rivers and flooding as well, which, tell us what we were having to look for.
Yeah, California's got a little bit of everything. That's what makes this state amazing and challenging to build in.
Terrifying?
So, yes. For sure, earthquakes is sort of what comes to the top of the list, is the main thing that we're focused on in designing new structures in California. But indeed, you get up into the mountains and you're dealing with significant snow loads, some of the heaviest in the country. And
why is that? Because it doesn't get the most snow of any place in the country.
Yeah, it's because the coastal mountains, the snow is generally heavier and wetter, and it comes in high quantities, indeed. Yeah, so coastal mountains, for sure.
Huh. And so I know that now, right, in the state of California, we've had all these things called atmospheric rivers. But when I was growing up, there was no such thing as atmospheric river. And we've had, I think, 13 now.
Yeah, it's been amazing.
So you actually see a picture of a place that I went skiing a couple days ago, and you see the snow load, and then a little building as we were driving out, there was as much snow on the roof as there was on the ground. And you could only see about a foot of the single-story house between the snow loads. So, what are the normal, like a house on the coast of California or in the Silicon Valley, what are the loads that you have to think about with respect to kind of not only like roof loads, because I know that you have a specific load or a weight of roof that you have to account for, but also floor loads, and then how do those compare to those same loads up in, say, the mountains?
Yeah, down outside of the mountains, the loads are fairly minimal on those loads. They're just service loads for the roofs and then occupancy loads for the floors, and relatively speaking, they're minor. You get up into the mountains and those loads quadruple, if not more, particularly for snow loads. In the Sierras could be 10 times as much of the roof loads or more. And for a while there, I was like, that is a lot of load. It's like a ridiculous amount of load to design for. But after a winter like this, you realize that they're exactly appropriate.
So what is the pound, I know that loads are given in, I think, pounds per square foot, right? Yeah. So what is the roof load of a house, say, in the Silicon Valley?
So basic roof load would be 20 pounds per square foot. And up in the Sierras, you can easily get up to 250 pounds per square foot.
Wow.
So that's that 10 factor plus. Yeah.
So the pictures that I showed earlier are kind of relevant, right? That snow is incredibly heavy. We were actually having to shovel snow off of the walkway, and it is unbelievably heavy.
Truly.
I mean, there's so much water in the snow. We always talk about Utah powder and how light and fluffy it is, and you can't even make a snowball out of it. You could literally make a rock out of the amount of snow here because there's so much water in it.
Yeah.
So you actually have a story about the snow loads in Tahoe where you stayed.
It's been a historic winter
in
Tahoe this year. It's like the second snowiest winter on record, at least. And the snow loads have accumulated. There was some of those cold, powdery weeks, but then soon after that, another couple of those atmospheric rivers came in that were really wet and heavy, a lot of rain, even at high elevation. Oh. So you've got huge quantities of snow, rain pouring on top of them. Everyone was out shoveling their roofs at that point before those atmospheric rivers came in. So the end of the season, just recently, on my house there, my neighbor's house, we're fairly close, but you would have thought a safe distance apart. This year there was so much snow on the north side of my neighbor's house.
Why is it the north side versus any other side of your house?
Good question. The south side sees all the sun in the summer, so there's typically a lot less.
So it just melts it?
It just melts, yeah.
Okay.
That radiant heat, even when it's cold out, does some work on melting the snow.
Okay.
The north side is in the shade almost all year long, all day long, so there's no meltage, very little meltage over there.
Okay.
And the accumulation just stacks up. So, as the days have finally gotten warmer, that north side on my neighbor's roof slid, and I essentially had an avalanche crash into the south side of my house. And it shook the whole house like it was a major earthquake. It was unbelievable. And I've got damage and cracking sheetrock throughout the interior of my house on that side.
Wow. So did that strain neighborly relations?
No, he's a good neighbor, and you got to help your neighbor out, especially in the mountains.
Wow. So that those different loads, I think that's really important to understand, is that every project we build has a different requirement. And we've talked in previous videos about the different environmental requirements for heating and cooling and light and wind, but we also have a lot of different requirements for structure. So a house that maybe is on the flatlands in the Silicon Valley, like we know that area has a lot of clay and what we're called expansive soil, and so we have to adapt to that type of project differently than we have to adapt to other types of projects structurally.
Yeah, exactly. California is a diverse place, and it's no different in terms of the challenges, the environmental challenges that we design these structures and homes for. The soil type, as you mentioned, down in Silicon Valley, often requires deep foundations that require to go through a lot of superficial soil, like at the surface, that to get down to stable, competent rock and/or soil material down below to support these houses.
So why can't you build it on? Is the soil above it? Is the problem that the house will sink into it? Or is there another problem?
There could be a couple problems. It could often sink. We call that settlement, just because that soil on the top is soft. And so if your house and the foundation supporting that house is not designed to work with the type of soil that's beneath it, it will compress that soft soil at the surface, and you'll get settlement and uneven, unlevel floors. There also can be, as you mentioned, expansive soil, which will actually, when it gets wet, expand and push up on the foundation. So it's really important to understand the type of soil that's particular to the location of the building.
And when you say it expands, it's not expanding uniformly. It's not like you're bringing the whole house up. You're bringing the house up at different levels.
Indeed.
Right? Yeah. And so that's probably the reason that a lot of our projects that we have, we'll actually walk into an old existing house and we'll say, okay, so tell us about your house. And they'll be like, well, we can open this door in the wintertime, but we can't open it in the summertime. And we can open this window in the summertime, but we can't in the wintertime.
Yeah.
So that's that differential settlement.
Yeah, exactly. That's a good example of a foundation not being designed for the type of soil that's at that location.
So that's actually a root fault of the original builders and not designing the house to the actual soil conditions that they experienced.
Yes.
Is there a way to fix that in existing houses?
It's more difficult to fix it than it is to do it right the first time. Like I think
that's always true.
My first grade teacher taught me that one. But yes, that's what we're dealing with in many cases. So it's more difficult to fix it, but possible.
Yeah, but very expensive.
Yeah, more expensive. Yep.
Yeah, so I remember in my house in the Silicon Valley had piers, but the piers were only 4 feet deep. And when I had a civil engineer come by to look at the layer of clay, it was 12 feet deep. And so we ended up having to put 15-foot deep piers around my entire existing house to put a second story on it, which added a lot of money to the budget that was really like throwing money into the ground.
Right.
I mean, because I didn't change the footprint of the house. All I did was add a story above the first story. Yeah. And so it was just, there's an old saying, a boat is like a hole in the water you throw money into. I kind of feel like foundations are like that.
If they're not designed right, yes.
I mean, we're going to talk later about basements and why basements cost so much, but I think it's really important to understand that every project, even projects like next door to each other, we've built adjacent projects next door, and they had different soil conditions that we had to adapt to.
Sure. Yeah.
Huh. That's difficult. So we also have a very condensed population, although not as condensed as places like Europe, where we have basically all the people kind of live in the basin of the Silicon Valley, and we have some houses on hillsides. How do we have to address, or how do you have to address foundation problem or foundations for houses on hillsides?
Yeah, the foundations on hillsides sort of ramp up the level of challenge and difficulty. Usually, first of all, it's always important to have a geotechnical engineer, but a hillside site is critical to have a geotechnical engineer, because throughout the hills in California, often they are prone to sliding, creeping down. There's a lot of downward landslides potentially. And even if not landslides per se, there's forces that are creeping downhill. So that's even more important for the foundation to be tuned and designed for that site. And that's where that geotechnical engineer comes in to help us better understand that.
So in the past, we've built two different types of foundations on hillsides, and specifically in places where there's landslides. We've had like 7-acre projects where the amount of space that we could actually build on was like 5,000 square feet of that 7,000 acres, or 7 acres, excuse me. And it was because 6.8% of that acre, or 6.8 acres of that 7 acres was landslide area. And the cities wouldn't allow us to build on the landslide areas, right?
Yeah.
And so the question was that, like, can we use what's a pier and grade beam foundation, which a pier is a large cylindrical drilled pier filled with concrete and rebar, to go down through that landslide, or is the force just too great for those piers to withstand that load?
It's possible, but it depends on the extent and the depth of that landslide.
Okay.
Typically, I think it's best to avoid it, like you did on that project, to find the area, and that's where find the area on that site that doesn't have the landslide is probably the most path of least resistance there. If you do get pushed into designing and building in the landslide itself, yeah, that definitely adds complexity. Oftentimes, in past projects where we had to do that, it took not only concrete piles, drilled piers as you described, but steel encased concrete piles. Additionally, with a very stiffened foundation design that was tied back into the earth at the uphill side of the structure. So it was significant forces, landslides that you're dealing with there. Yeah.
I remember
that are actually they're actually triggered during earthquakes. So it's like a dormant landslide that during a shake can cause it to
So you get a double whammy.
Double whammy. We essentially built a concrete supporting structure on concrete piers that was designed as if this earthquake activated this landslide, that it would be standing like a concrete tree fort at the end.
No way. Yeah. I remember like 12 or 13 years ago, we built a house on a hill, and it was all in landslide area, and there was no way to drill through it. And the structural engineer on that project built the foundation was a grid, like 10 feet on center grid, so it looked like a waffle grid. And the grade beams, which are the members on the ground, were 2 feet wide and 3 to 4 feet tall, and had enormous rebar. And we'd never actually built something like that before. And we asked the structural engineer, like, why the foundation was so burly, and he goes, "Well, I can't stop the landslide from happening, but I can keep the people in the house safe." And he said, if a big earthquake hits and that hill lets go and slides, the house is just going to ride on top of the landslide. And he goes, the house will still be safe, but you'll have a different address. And he was kidding, but like not kidding. And I thought it was like terrifying. I mean, it was like great. Like, we were happy that the house is still going to be standing, but the whole idea of having it to change your address was a little bit like a kind of kick in the head, right? And we told the client this, and they're like, huh. Yeah. But that was like, it wasn't a huge site, and that was the only place to build the house. And so we are so starved for buildable land in the Silicon Valley that we have, the state has gotten involved in requiring houses, existing single-family houses, to allow ADUs, so accessory dwelling units, additional dwelling units on those lots, just to provide more housing for the people that are here. because we have some of the most expensive housing anywhere in the world.
It's an incredible situation, isn't it?
Huh.
Yeah. We've designed, that approach is not uncommon sometimes
Really?
to design such a stiff foundation. We sometimes call those rafts or mat foundations that will essentially go for the ride during a landslide or an earthquake event. That then the idea is that it meets that life safety, which is always our performance goal, and the code required minimum goal, and that they have stiff enough foundation that you can re-level those.
Oh, wow.
And get it back to not only provide life safety, but theoretically re-level those to after the post-earthquake.
So you can get a new address.
And yeah.
So California, as we've talked about, is a very unique place for lots of different reasons, and it's also the Sunshine State, which is a huge draw.
Yes.
After 13 atmospheric rivers this year, it's really nice to see the sun outside. I'm interested in how does that differ? What do you have to do differently in California than you would have to do a place like Kansas, where you don't get hurricanes, you don't get earthquakes? You don't have these.
The ground is flat.
Yes, the ground is flat. Like, how is it different from building here than it is building there?
I mean, it's all about safety, right? And we're if we want to live in this sunny state of California, we got to make sure that the structures are built safely. So that means dealing with these natural hazards that we're talking about, or the earthquakes, soil conditions, and I think that's pretty much where we're at.
So do you put shear walls on houses in Iowa or Kansas or someplace where you don't have these natural kind of seismic events or wind events?
There's such minimal events out there, or minimal forces to design for, that there's prescriptive codes. You almost don't need a structural engineer in there. You just need a good builder.
Really?
In these cases, yeah.
Wow. Yeah, you didn't hear that. You always need a structural engineer. I'm just kidding.
In California, for
yeah.
sure.
So tell us how the forces for an earthquake differ from the forces for like a hurricane or a tornado.
Essentially, we end up designing the homes similarly. Usually, one of the initial analysis that we do is compare wind loads and wind, like for associated events like hurricanes, tornadoes, potentially, or just high wind loads, more commonly in California, with earthquakes, and one of them governs. But whichever one governs, then automatically that design will handle both the wind and the seismic. Typically, seismic governs in California, but the design is more or less the same.
Oh.
So we cover both aspects. We just find the one that's more demanding for the particular site.
Awesome.
Yeah.
So it's basically the most stringent code wins, and your house is built to that level, and you get to kind of free hurricane resistance on your earthquake-built house.
Maybe not hurricane, but
Yeah.
if it was hurricane, that might actually govern over the seismic.
Oh, really?
Potentially, yeah.
So
With
hurricanes-
certain components, at least. Yeah.
Oh, wow. I don't think we've had a hurricane in California in a long time, but
so,
hopefully not.
Yeah.
I hear we're about to have a lot of flooding from the 200% snowpack.
There we go. Yes.
And that, I mean, as we've seen from the videos from Japan where they get the tsunamis, the water loads must just be unbelievable.
Yeah, for sure. The water and flooding is a whole nother load to deal with, but hopefully those areas have been identified at least in our current codes, which is good to have. And those current structures at least are built for the flood zones, and there are certain detailing and design requirements for those zones.
Really? Yeah. So you can actually design around a flood. Is it just about lifting the house up off the ground far enough so the flood goes underneath, or is it?
Good question. That's part of it. It does even if there's a basement, then the basement would be designed for it. Exactly. So you don't necessarily have to be above the floodplain, although it depends on the jurisdiction.
Huh. Yeah. How do you design a basement for a flood?
Well, you have kind of two main strategies. Either you have to verify that the weight of that can counteract the uplift forces from the water.
So it doesn't act like a boat and float out of the ground.
Exactly, because you have to design it like a boat to not let water in those cases, to keep the water out. But if the water starts pushing up on it and getting underneath, it will lift the structure. So you either need to verify that there's enough weight to counteract that potential lifting motion, or sometimes we'll have to drill piers down to hold it
to anchor it.
To anchor it, yes.
Wow. And so the difference between those two types of projects would be whether you would choose one versus the other would just be about cost.
Exactly. Yeah.
So we've gone through the structural engineering work process, and we've talked about lots of different projects in California and outside of California and all the forces that we have to account for in California. If you're interested in learning more about building science or about conversations like this or following our projects, hit subscribe as we show you how to build a better way.